And welcome to Detecting Credential Compromise in AWS. Just a quick show of hands. I assume most people in the room are familiar with AWS, but is anyone a practitioner? You'd raise your hands. I think I could see people out there. So yeah, quite a few. It's great to have a crowd here this morning. But first, who am I? Why am I here to speak with you today? My name is Will Bengtson. I am a senior security engineer at Netflix. For those of you that aren't familiar with Netflix, we are a microservice ecosystem that streams video, and we're running 100% in AWS. So up until that point, when you actually press play, all interactions happen within our AWS infrastructure. The team I'm on is the Security Tools and Operations team. We're not like your traditional SecOps team, where we're not the SOC, we're not the incident response team, but we actually own our AWS infrastructure and the security and the accounts therein. So we control permissioning and, most importantly, monitoring of those accounts. If you're interested, the slides will be posted later today. Some cool presentations that folks from the team have done. If you want to follow me on Twitter to continue the conversation afterwards, I'm at __muscles, and that's my GitHub where I'll be open sourcing something later today. But first, I just want to start saying this is not a machine learning talk. I wish I could say that I created this really awesome model and put in all these different data sources and learned and was able to come up with something really awesome. In fact, I think I did come up with something awesome, but it was very simple. And so I always say, why do something complex when it can be pretty straightforward? And I think I'll show that in an architecture diagram later of how simple this actually is. The scope of the talk today is detecting compromised instance credentials outside of your environment. And your is very important here, because when I say your or my or our, that means Netflix's environment, your own AWS infrastructure, not just AWS in general. For those that aren't familiar, when you launch a service in AWS, you get session credentials that are automatically refreshed. This is from the security token service that AWS provides. They will manage rotating credentials on your instance for you, and you can also use this service for distributing keys within your individual employees yourself. The STS tokens aren't the only type of key in AWS. You have your root keys, which are like your root user in Linux. Hide those. You'll never need to use them unless you lock yourself out of an S3 bucket or need to change the account billing information that is restricted to root. But mostly you'll be interacting with these session tokens, and that's really what I'm focusing on here today. It can be applied through any type of temporary credential in AWS as long as you understand how those are created. And you could potentially apply it to the IAM user static keys as well. So what's the problem? I really was out attempting to solve detecting compromise or credential misuse really outside of our environment. And so at AWS or Netflix, we have hundreds of thousands of servers. They change constantly, 4,000 or so deploys a day. I mean, we're continuously deploying and changing our environment. And so I really wanted to know when was a credential being used outside of Netflix, not just AWS. So I started asking, who's doing this well? And from what I can gather publicly, no one. If you're doing this well, please raise your hand and find me after this talk. I'd love to collaborate. There's services provided by AWS, such as GuardDuty, that allow you to detect when a credential is used outside of AWS. But if you think of the landscape in AWS, it's huge. It's Netflix, it's Slack, it's every company running, including the attacker's infrastructure. So if I'm a bad guy, I'm going to take your credential and use it in my infrastructure and fly under the radar. So we really wanted to detect outside of your AWS infrastructure. So why is this so hard? For us, at least, it's a scale problem, and I'll get into why it's so hard for us, but many others might have that problem as well. As you get familiar with working in the cloud, you understand that you have to make API calls to describe your environment, and there's some limitations that you'll run into as you scale up. So we really wanted something that worked regardless of what size you're running in the cloud. What tools are there? I'm sure there's a mixture of tools that you can use, but the main tool we're going to use today is actually provided by AWS, and that's CloudTrail. For those that aren't familiar with CloudTrail, it's an audit event history of API calls in your environment. So anytime you're in the console, using the SDKs, the command line, or any other way that you're calling API functions, you get a log. Now there are some gaps in this log, which I'll cover later, and how to address those. But for the most part, you can understand what calls are being made in your environment. And just recently, Amazon made 90-day event history free in the console for you to use. So there's really no excuse for you not to be auditing this data. One of the most common ways of getting this data delivered to you is utilizing the S3 delivery function, which we use at Netflix. And so if you're interested, that's kind of what the file name looks like if you're having files delivered. But note the S3 file delivery is up to 15 or 20 minutes delayed depending on your size and how much data they're actually trying to write for you. So this method using this stream is going to be delayed based on the actual time to detect from the first call from the attacker. If you aren't familiar with CloudTrail, there's a couple fields that I want you to pay attention to today. You have the user identity field. In our case, we're going to be focusing on the ARN. Event source and name are actually the service and the API call that's being made. But the most important piece for us today is source IP. And that's what we're actually going to be looking at as we do this analysis. And user agent is also something that I'll touch a little later on. At Netflix, we have many, many accounts. This is a common architecture for delivering CloudTrail. We have every account delivered to a single bucket, and from that point forward, we can have a notification topic go off to many, many subscribers, whoever needs to process that data. So this is, I think, one of the best practices from AWS and something that we recommend if you want to centralize CloudTrail. It doesn't stop you from having CloudTrail in each account and just distributing your orchestration or your infrastructure that's monitoring it, but we just choose to do it centrally for us. I first tried to tackle this problem a while back, and I went off to try to define some requirements. And those requirements were, I need to know all IPs in our environment at all times for the last hour at least. That way, when I actually get the CloudTrail data, I can do this sliding window kind of analysis and ask the question, did we have this IP for this event in CloudTrail? If we did, no big deal, we continue on. If we didn't, then it's something we might flag, right? It might be a compromise, it might just be a misuse of credential from an employee, but something we should dig in deeper on. But as I mentioned, there's some problems you might run into as you continue to grow in the cloud. And with AWS, and I'm sure it's the same with GCP and others, there's pagination in the API calls and then rate limiting. What I mean by pagination is if you're just trying to describe your servers in AWS, you make a call called describe instances. AWS is going to give you all of your servers back at once. They're going to give you a subset, and then they're going to give you a page marker. And if you want to continue describing your environment, you can continue sending that marker on, and the next request will give you a new marker, and so on and so forth. For us, it can take up to an hour to describe our production environment just due to our size. So if you think of the requirements previous where we were trying to understand what IPs we had in our environment for the last hour, it's almost impossible. For how many changes we have in our environment, we would potentially miss a lot of infrastructure that we had for a brief period of time but was auto-scaled out or chaosed, if everyone's familiar with our chaos engineering practices. But as we paginate through our calls with Amazon, we constantly run into rate limiting, and this is a protection Amazon puts in place so that you don't just do a denial of service on their service endpoint. So it makes sense, but we have to think about these problems when we're doing things at our scale. And so I really wanted to solve it without having to run into these issues. So I came up with a new approach, and it is based on two real things, and that's using an understanding of AWS and how it works. I can't stress this enough. If you understand AWS and what's logged and how it's logged, you can go a far and a long way. But use AWS, how it works, to our advantage, and then make a strong but reasonable assumption. And if we can do those two things, then I say that we can profit and detect credential compromise. And in this approach, I mentioned the temporary credentials that AWS provides. On a server, Amazon will create those credentials that are valid anywhere to 1 to 6 hours. And they'll actually rotate those credentials for you. They'll provide them through a metadata service, which I'll speak about here shortly. But because of this fact that the credentials are short-lived and up to a 6-hour window, we can get full coverage in our environment from the minute you put this in place in up to 6 hours. It can be much shorter, but depending on when the last credential was issued in your environment, it's up to 6 hours. So from zero coverage to full coverage in 6 hours, which I think is pretty cool. And not only in real time can you do this, but also historically, over old CloudTrail data. If you're just interested in understanding, have we had a misused credential in the past, you can run this over past data as well. So first, how does AWS work? Given that you're deploying a server in the cloud, there in the middle, there's multiple parts actually interacting together. The Amazon EC2 service is going to ask the IAM service for credentials for your instance, so that your application can actually make API calls in AWS. So it's going to do an assume role call by the EC2 service. The IAM service is then going to pass credentials back to the EC2 service, which is then going to pass those into the metadata service. Now, the metadata service is something that's mounted into your VM and available with a common address of 169.254.169.254. Now, I believe that's common across the cloud providers and something that even the attackers know, and we'll cover why that's important. But the metadata service has information about your instance, where, what's the IP, what region or availability zone is it deployed, any type of user data that you're injecting at launch, but most importantly, credentials. And so once the metadata service has these credentials, they're valid for 1 to 6 hours. They're automatically refreshed. But when your application goes to use them, they'll reach out to the metadata service, create a session or a client object, and then you can go make API calls to the service of your choice. Now, the way that CloudTrail works is CloudTrail is a service within Amazon, and services have the ability to log what they want or not log what they want. So CloudTrail can't really control it, but they offer it as a service internally. And so depending on the API call you're making, there might be an CloudTrail call. Most likely on mutating events or any event that changes your environment, you'll see these, but there is a gap in data events, which we'll cover. So that strong assumption I mentioned is pretty simple. It's basically first call wins. So we're going to keep track of when Amazon's making session credentials. We're going to store those in a table, and we'll walk through an example here. And as we see the first use of that temporary credential, we're going to grab that IP address and lock it. And that's going to be the IP address that we hinge upon. And so without requiring any knowledge of the IP space, we can grow the session table and understand what IPs should we actually see API calls coming from. And from that, alerting is pretty simple. If you were to look through this diagram, the pink boxes would show you the path to detection. So if you're processing CloudTrail, you're going to get files, and you're going to process event after event. Every file has up to thousands of events in it. So you're going to sort those events by time. You're going to go through and process each CloudTrail record and event one by one. We're going to look for the assumed role call by EC2, and we'll show actual CloudTrail examples here shortly. As we see that, we're going to look into our table and say, do we have a record of this already? If not, then we're going to go add it. We're going to add a TTL for 6 hours. And that TTL is really just going to allow us to clean the table up automatically in the DynamoDB fashion. If it's already in the table, then we know that that instance is still up, that role is still being used, and we're just going to refresh the TTL. So you can continually update. If you look at the table after the 6-hour window, you would know every session credential issued for your environment. So once we have a table built, we're then going to look for the assume role session tokens being used. And you can do that by looking at the type of the call or the type of the identity in CloudTrail. If it's in our session table, we're going to continue on. If it's not in our session table, we can't make that accurate guess or that accurate assertion that this is a potentially misused credential. So we're just going to throw that data away. You can opt in to saying first time on any session, we're going to lock to that, but we've chosen on this initial implementation to at least throw it away. We're going to get coverage within 6 hours, so it's not really that big of a deal. So once you're in the session table, or once it's in the session table, you can then go look, is it AWS making a call on your behalf, which we'll go into edge cases here in shortly, or is it an IP that we whitelist? Maybe we allow users to pull credentials down for the VPN. If not, then we're going to go look and say, do we have the source IP in our table already? If we do they match? If they match, then we continue on. If they don't, then we alert. And if we didn't have a source IP in the table, then that's when we'd add it to the session. So it's basically you're doing this kind of flow each event. And you eventually make this table that lists every temporary credential in your environment and what IP they should be coming from. I mentioned a simple architecture diagram. I debated whether I should actually throw this slide out because it's the first time I've ever done a diagram that was a single line. If you've done this or done this many times, please let me know because I need some pointers. First time it's happened. So we can start with a table like this. We have an identifier, a source IP, the ARN that we're actually interested in, and then our TTL value. As we analyze CloudTrail, we're looking for that initial assume role call, which is from the event name, and the pieces that tip us off of that is source IP address is actually going to be registered as the service EC2. And user agent will be the same, and as well as user identity is AWS service invoked by EC2 Amazon. So once we see that, we can actually go into request parameters, which Amazon EC2 service is very nice that when they actually create the temporary session, they're going to create it with an instance ID. So you can track the temporary credential down to the instance level and know exactly what instance is compromised. From here, we can see that the role that they're assuming is my cool role, and that's what we're going to track on. So if we took this entry and actually went to populate a table, it might end up looking something like this. We leave that source IP blank initially until we actually see the first call. You continue to process more events. You'll come across more assume roles. You'll come across things that you don't have in your table. But once you come across something that you know, you can see that it's a type assumed role. So we know it's something we care about. The ARN is assumed role, my cool role. And we can see that the session identifier, which is everything after the role name, so anything following the final slash in an assumed role ARN is your session name. We can see that it's marked to an instance ID. So we know it's probably something we might have, or it's something that we're throwing away and we'll have at some point. If we're interested, we can go down and see what was actually called. So in this case, someone was describing instances in the environment in the region US West 2. The most important piece for us, of course, is the source IP of 52.95.255.121. If you're familiar with the Amazon IP space, you know that's an Amazon IP, so we can actually go in and add it to our table. So now we have our initial session and IP locked. So if we come across this again, we can do the analysis and say, does this match or does it not? So if we continue processing CloudTrail, we can see once again we have a type assumed role. It's the ARN, it's a temporary credential for my cool role, and the session looks like something that we just saw. If we're interested, once again, we can actually look and see what the event name or source is. This might not be interesting until you trigger an alert, but something you might still want to do alerts for. There are dangerous calls, but that's outside the scope of this talk. But most importantly is the source IP address, 52.95.255.121. So we go back, we see that we have the session. Our hash key in a Dynamo table scenario is the instance ID. It's unique globally, so don't worry about collisions across your accounts. But we can ask that question, do these two IPs match? In our case, they do. So we can say this is good, continue moving on. So you do this process over and over and over. And eventually you might come across something that should look familiar by now. It's my cool role, the instance ID that we're used to. The event name is getCallerIdentity, which is probably suspicious in itself. If you aren't familiar with AWS, getCallerIdentity is similar to who am I on a Linux machine. There's no real good reason to call this in your account. If you see this, it's probably someone wanting to know what account they're in, because you can pull the account ID from, but there's other ways to get that account information, so I urge you to work with the teams to change their way of life, because this is something common that an attacker might do when they come across credentials is, who am I? Is this juicy? Should I use it? And this call works regardless of permissions in AWS. So as long as the key is valid, this call will work. But once again, our source IP is what we really care about. And in this case, it's 67.178.52.232. This is a San Jose IP. It's most likely my house for this demonstration. And this is another question that we ask, does this match? So in this case, we know these two IPs don't match. So this would trigger an alert of potentially compromised credential. A employee or engineer has pulled credentials down and used it off VPN if it's a whitelist. But we at least know here that a credential is not being used inside your environment. So this could be from a different AWS environment that's not registered in your account, and you would alert on it. So I think that's pretty powerful. I mentioned a few edge cases. As you can continue to monitor CloudTrail, you'll find that anytime Amazon does something on your behalf, you're going to see the source IP show up as a service name.amazonaws.com. This is whether support is looking into your account for a ticket, autoscaling group is autoscaling your service, or there's actually many calls that you make that Amazon takes your credentials and makes some calls on your behalf to make your life easier. If you're restoring an encrypted database, for example, Amazon will go make KMS calls on your behalf. So they'll take your credentials and use them, and you'll see that show up in CloudTrail as an Amazon source. If you're using VPC endpoints such as the S3 endpoint and you have CloudTrail turned on for S3, you'll actually see the calls through that endpoint show up as a private IP. So you need to have some logic for first public, first private IP pair, and that private IP ending up in the IP space for that environment. And then also you might have a scenario where you launch an instance and you want to attach an elastic IP because you're public and you want the IP to always be the same, or you attach multiple ENIs. With that case, you might have a change in the IP that your call is coming from. So we recommend looking for those calls and then putting into a temporary table and say, we saw they tried to attach a new IP, we'll accept one deviation from this list, but only for this amount of time. Because if you're attaching a new IP, you should see calls from that new IP within minutes. So you can set that TTL on that table very short and minimize that risk that in that time frame an attacker were to actually get your credentials. If you were to avoid detection, one of the most common ways credentials are pulled from environments is through server-side request forgery. This is where you've actually tricked the application to pull the instance metadata yourself. It's a very common tactic for applications and researchers if they know you're running in AWS. Most likely it's a critical vulnerability to the bug bounty that you're submitting to. What researchers don't know is that they could actually use those credentials, sign an API call, and use that same attack vector through SSRF to make that call. In that case, it would actually come from the IP of the server, and you wouldn't be able to detect it. So in that scenario, you'd use a user agent and make sure that it's something that Amazon CLI or SDK would use. If you have an attacker on the box, obviously you have other problems, and you're probably not going to detect compromise unless you're looking at call anomalies and saying we've never actually made that call before from the service. So quickly wrapping up, I've got 2 minutes, and I'm happy to take questions in the wrap-up room, which I think is Pacific B. But understanding AWS and CloudTrail will make your life easier, especially from a monitoring standpoint. When we asked the CloudTrail service what is logged, they told us they did not know. So today I'm open sourcing a tool called Trailblazer that will enumerate all API calls in your environment and associate that call with what is actually logged in CloudTrail. So not only are you seeing is it logged, but you're seeing what it's logged as. There are some calls in CloudTrail that are logged differently than the actual API call itself. And you can flip a switch on this and actually use it as an attack platform to test monitoring in your environment. So with a simple YAML file, you can chain together calls in order to test your monitoring as well. And then also we're open sourcing an example implementation of the method I described today in Python in the Skunkworks repo of our GitHub for Netflix. So if you're interested in running it across CloudTrail data offline, there's an example of how to do that there. And you can take that code and modify it at will and actually adapt it to your architecture and how CloudTrail is actually delivered. But with that, I thank you all for coming, and I'll be available after this for questions.